Welcome back, everybody, to Daily Mass Concepts. I'm glad to have you. What we're going to be looking at today is multiplying matrices. We're going to be looking at the compatibility tests. Not all matrices can be multiplied. So we're going to be testing to see when we multiply and how we go about multiplying matrices. Again, please subscribe to this channel. And if you have not yet dropped a comment or anything, please do so. You can also request topics that you'd love to see. All right, so I'm looking out for that. See you. Let's go. All right, so we're looking at multiplying matrices in this section. So as you can see, there are two things here that we want to make note of, right? And it says here, and I'm reading, it says the number of columns in the first matrix must be equal to the number of rows in the second matrix. So that is something that we have to take note of when we're going to be multiplying matrices. All right. Also, it says that the resulting matrix will have the number of rows from the first matrix and the number of columns for the second matrix. All right, good. So what is that those two things are actually saying? We're talking about the compatibility testing to see if things can be multiplied. So let us do some quick testing here. Situation one. Let us say we have a matrix, say we have a 2, 3, and we want to multiply this by a 4, 1. Normally, what we want to do is to write down the order of both matrices. For example, the order of the first one is a 1 by 2, and the order of the second matrix is a 2 by 1. If you are not aware of the order of the matrix, we did a video on that previously. What it really looks on is the number of rows with the number of columns. So with this compatibility test, you could see that the number of rows, the number of columns in the first matrix is equal to the number of rows from the second matrix. So this means that they can be multiplied. The result of the matrix would be, as you could see, the row from the first matrix and the column from the second matrix. So we're looking for a matrix of the order 1 by 1 for the result. All right, so that's basically what we're talking about when we're looking at the compatibility test. We write on the order of the matrix or the matrices, and then we look to see. So normally I'll say that the two inner numbers are the same. Yes, we can work. All right, and then the two outer numbers will normally give the new shape or the new order for the result. All right, let us start off by doing the same thing here. 2, 3, we'll multiply this by 4, 1. All right, I want to multiply that by the matrix 4, 1. Now, remember, when you're multiplying matrices, it's simply row by column. So a row by column. So each row, this is a row, must be used to multiply by as many columns as possible. So then the first element from the row will go with the first element in the column, and the second element from the row will go with the second element in the column, and we add that result. That is just one response. For example, 2 times 4 plus 3 times 1. And that will give us our response. Let us look to see what we get. 8 plus 3, and that is 11. As you could see, we were expecting to get a 1 by 1 matrix because the order was a 1 by 2 that will go with a 2 by 1. This will tell us that it can work. And these two tell the result of the new matrix. And you could see it was a 1 by 1, which is exactly that. All right, let us continue looking at more ideas. Let's do our compatibility test. Matrix A, and if I should call this matrix B, from matrix A, we have a 1 by 2, and from matrix B, we have a 2 by 2. These two numbers here will suggest that yes, they are compatible to be multiplied. These two on the outside will give the result, which is the order of the result. So the order of the new matrix in the end is a 1 by 2. So technically, my answer will look like matrix A. Let us start off by putting the ideas together. The concept remained the same, row by column. Now this row, I could call it row 1 since it's just 1. And we have two columns here, column 1, we have column 2. Row 1 will be used to multiply by column 1, and when it's done, it's going to be used to multiply by column 2, which means that the row must multiply by all the columns. The row from the first must multiply by all the columns from the second. Let us go. We're going to be getting 2 times 4 plus 3 times 1. We're talking about 2 times 4 plus 3 times 1. So that is the first row with the first column. Then we're going to move across to the next column with the same row from matrix A. 2 times negative 2, then 3 times 5. So we're going across. So it's going to be a 2 times negative 2 plus 3 times 5. Let's put this together. This is 8 plus 3, and then we have negative 4 plus 15. This is 11, and this is also 11. So you could see that we do have a 1 by 2 as the order of the resulting matrix, but we were expecting that. Now, let's look at having 2 rows and 2 columns. So let us say we have a 2, 3, and a 1, 7. We're going to multiply this by a 4, 1, negative 2, 5. Now, you could see what we have here is a 2 by 2 matrix that will be used to multiply by a 2 by 2 matrix. The compatibility test says yes, since the inner numbers are the same, it will work. The resulting matrix, however, will be a 2 by 2 as well. So we have just sorted out that. Let's go about looking at how we multiply. We have row 1, we have row 2, then column 1, then column 2. Row 1, as you could see, is 2 and 3. Row 2 is 1 and 7. Column 1. Column 1 is 4, 1. Column 2, negative 2, 5. So let us go about doing the row by column. The thing is, each row must multiply by all the columns first before you switch to the next row. It simply means then that row 1 will multiply by column 1, then row 1 will multiply by column 2, then row 2 will multiply by column 1, then row 2 will multiply by column 2. And we're going to be getting the responses just as these line up in the same position. So let us go. We're talking about 2 times 4 plus 3 times 1. So that is row 1 times column 1. Then row 1 times column 2 will be 2 times negative 2 plus 3 times 5. Now we're finished with row 1. Row 1 gave the responses for the top. Now row 2 will give the responses underneath. 1 times 4 plus 7 times 1. Let's take a look. 1 times 4 plus 7 times 1. Then we're going to 1 times negative 2 plus 7 times 5. So let's go. 1 times negative 2 plus 7 times 5. Let's put together these values. 8 plus 3, negative 4 plus 15, 4 plus 7, negative 2 plus 35. Finally, we're getting 11, 11, 11, and 33. So as you can see, this is the result of multiplying those two matrices. Our result is a 2 by 2 matrix as we had expected. As you can see, we have row 1, row 2. Then we're looking at column 1, column 2, column 3. These rows will be used to multiply by all of these columns one by one. The shape that we're looking to have is that row 1 will go with column 1. Then row 1 will go with column 2. Then row 1 will go with column 3. Matrix 2. Row 1 from matrix 1, or you could say matrix A, will be used to multiply by all the columns in matrix B. Then row 2 from matrix A will be used to multiply by all the columns in matrix B. And the results will be in that order. Let us go. 2 times 3 plus 3 times 2. We're talking about 2 times 3 plus 3 times 2 right there. So we have 2 times negative 1 plus 3 times 0. Still using row 1, 2 times 1 plus 3 times 5. Then we're going to row 2. 1 times 3 plus 4 times 2. So row 1 times column 1, then row 2 times column 1, then row 2 times column 2. Talking about 1 times negative 1 plus 4 times 0. Row 2 times column 3, 1 times 1 plus 4 times 5. Let's put together the numbers. 6 plus 6, 6 plus 6. We have negative 2 plus 0, 2 plus 15. We have 3 plus 8, negative 1 plus 0, 1 plus 20. 12 minus 2, 17, 11, negative 1, 21. There it is. Thank you for watching Daily Math Concepts. Please like, share, subscribe if you have not done so. See you next time. Bye-bye.